Hi, welcome to your Dosage and Calc practice problems set 2, which are reconstitution problems. So there are 20 problems that I put on this set, and I'm going to go through working those problems. So if you have not worked the problems on your own first, I highly suggest you do that prior to watching this video. I think that you're going to get a lot more out of it if you at least attempt to work the problems on your own first. And I know that we've covered stuff that's a little bit past this at this point, but I want to make sure that we have all this stuff down really solid right now. So all of these problems are using drug labels, so I thought that would be good practice for you to really be looking at these drug labels. And a lot of them are the same ones, but at least it's a little more practice at reading drug labels and kind of discerning what information you need to pull off of there. So, okay, without further ado, let's get started. Question number 1, the prescriber orders Keflin or cephalothin 400 milligrams IV Q6 hours for a client with an infection. We're going to add 10 mLs of 0.9% sodium chloride, also known as normal saline, for diluent. How many milligrams are in this vial? Well, I can look at this label and I see that it's 1 gram, so I know that's 1,000 milligrams, right? No math involved there. How many milliliters will the nurse administer? So we are looking for milliliters per dose. And I'm looking on here and I don't see listed anywhere where it says any sort of concentration. So I'm going to go with knowing that I added 10 mLs of 0.9% of saline for diluent. Yeah. So I'm going to say in 10 mLs, I have 1 gram, right? Got my milliliters, got my numerator, and I've got this gram hanging out here. I need to get rid of that next. My order is in milligrams, so I need to convert. 1 gram is 1,000 milligrams, and I've got 400 milligrams per dose. All right, so checking over my problem, I'm left with milliliters per dose. That's what I'm looking for. I'm always going to start out with what I'm looking for in step number 1. Step number 2 is going to be my numerator, and I'm going to work my way across the problem, just like with all of our problems, but just a little reminder. And so now I can do the math. I've got, I'm going to multiply all the way across. 10 times 400 divided by 1,000 equals 4 milliliters per dose. Now, if you look back at the top of this, you see I put our rounding rule for all problems. Greater than 1, round to tenths, less than 1, round to hundredths. So this comes out even anyway, so no rounding involved. But okay, so how many milliliters will the nurse administer? We're going to say 4. How many doses are in the vial? And I actually just have this here because I want to use this as an example of how you can use dosage or dimensional analysis to figure out different kinds of problems. And even though this isn't the type of problem that you'll get asked on any of your ETSU math tests, I just want to show you how you can use dimensional analysis in other ways real quick here. So how many doses are in the vial? So if I'm going to answer that, I am looking for, all right, why isn't it writing? All right, let me pause here for a second. I'm having a little technological issue. Okay, not sure what that was all about, but okay, here we go. So, okay, so I want to know how many doses are in the vial. So I'm going to say doses per vial. All right, so this looks a little different, right? Okay, stay with me. I'm going to again start with my numerator. And I know that one dose is 400 milligrams, right? So one dose is 400 milligrams. I'm going to convert. My vial is in grams, and even though I could do this in my head, I'm going to do it the right way here. I know that 1,000 milligrams are in 1 gram, and 1 gram is in this vial. So I'm using dA just like with all my other math problems to figure this out. I've got 1,000 divided by 400 equals 2.5. So I've got 2.5 doses per vial. So there you go. All right, there's something we haven't covered. Okie doke. Client with an infection receives ampicillin 500 milligrams IV Q12 hours. How many milliliters of diluent should be added? So this vial label does not give a dilution for IV. So I'm going to use the IM dilution here. And I just want to see, and if I saw that, I'd be like, oh, wait a minute, am I okay to use this for IV? Okay, well, I am because it says so right there. But for purpose of this, the purposes of this math problem, we are going to use this one. So I'm going to add 1.2 mLs of diluent. How many milligrams are in the vial? 125. How many milliliters will we administer for each dose? So I want to know milliliters per dose. And I look on here and it says I've got 125 per ml. So 1 ml is 125 milligrams. And my order's for 500 milligrams per dose. Okay. 500 divided by 125 equals 4 mLs per dose. 4 mLs. How many doses are in the vial? There's actually less than 1 dose, right? Per vial. And I could figure that out using the problem up top. You know, do that the same way as that I did that one, but I'm gonna leave it at that. Okay. Prescriber orders penicillin G potassium 1.2 million units IV Q4 hours for client after dental extraction. Vial contains 1 million units per ml. And so that would be right here that this has already been reconstituted. So we're not figuring out how much diluent in this problem. So I've got 100 units per ml. How many mLs will the nurse administer? So I'm going to say milliliters per dose. Oops. I don't know what that was. Milliliters per dose. Okay. And 1 ml is 1 million units. My order is for 1.2 million units, which is 1,200,000 units per dose. Milliliters, dose, units, there we go. 1,200,000 divided by 1 million, to make sure I have the right number of zeros in here, is, no, wait a minute, that's not right. 1,200,000, always double check. 1,200,000 divided by 1 million. There we go. 1.2 came out with 12. I knew that wasn't right. 1.2 milliliters per dose. Now, if I look back to my rounding rule, I am greater than 1, so I'm going to round to the nearest tenth, so we're good to go there. 1.2 milliliters. Okay. All right. Client has an order for 2 million units of IV Pfizer pen or penicillin G potassium, Q4 hours, ordered for a severe pneumococcal infection. How much diluent will the nurse add for a concentration of 1 million units per milliliter? Well, we saw that on the last one, so it's right there. So it's 11.5 milliliters. And how many mLs will we administer? So milliliters per dose. We've got 1 ml, again, is 1 million units. Remember, whenever you're doing problems that are in units, you have to write units out. You cannot abbreviate that. It has to be written out. You will get marked incorrect if you don't write it out. So order is for 2 million units. I know these problems have a lot of writing. Per dose. Units, milliliters, dose. We're good. 2 million divided by 1 million. I don't even need a calculator for that, right? 2 milliliters per dose. Okay. Pretty simple one, right? Okay. I need to pause again for a second. Pardon me. You can probably hear a timer going off in the background here. All right. Come on now. I can pause. Ah, there we go. All right, sorry about that. Okay, the client with osteomyelitis receives penicillin G 600,000 units, IM, BID. How much diluent should be added? Well, if I look at that, I can look and see my diluent options here. And the easiest thing to do would be to go for the 100 or 200,000 units per ml concentration, right? I mean, that makes your math just a touch easier. However, if I look at this and I say, this is IM, so I'm a nice nurse, right? I'm going to give my patient an IM shot. I want this to be the least amount of volume as possible because, you know, it's going to hurt less, right? So I'm going to go for the most concentrated option here, which is going to be option number 3 right there. 1.6 mLs is going to give us 500,000 units per ml. So that's what we want to do. The least amount of volume as possible. Okay, the medication concentration then would be 500,000 units per ml. Okay, so how many mLs will the nurse administer? Okay, mLs per dose. And we've got 1 ml is 500,000 units. And my order is for 600,000 units per dose. So 600,000 divided by 500,000 equals 1.2. And 1.2, that's getting me to tenths. I've got an answer greater than 1. I need to be at the tenths mark, so we're good there. 1.2 mLs per dose. All right. 1.2 mLs. Okay, that's it for that one. Client has a Pfizer pen or penicillin G potassium, 400,000 units IV, Q4 hours, ordered for a severe strep infection. The nurse adds 75 milliliters of diluent, so that's going to be that line right there. And how many mLs will the nurse administer? So mLs per dose. And we're going to say 1 ml is 250,000 units. And my order is for 400,000 units per dose. So I know a lot of these problems are somewhat similar, but we are kind of picking out different info off of the labels and stuff too. So this is all good practice for you. 400,000 divided by 250,000 equals 1.6. Rounding to the tenths, we're already at the tenths, so we're good there. 1.6 milliliters per dose. Okay. All right, number 7. I promise you we'll get into harder problems on the next set of problems that we do. So, okay, the client has penicillin G, potassium, 300,000 units, IM, Q4 hours. How much diluent needs to be added for a concentration of 250 units per ml? So I'm going to look on my little chart on the label there. I want 250,000 units. That's going to be that first line right there. I'm going to add 18.2 mLs. And how many will we administer? How many milliliters will we administer? All right, so 1 ml is 250,000 units. Order is for 300,000 units per dose. That was messy. Per dose. 300,000 divided by 250,000 equals 1.2 mLs per dose. Okay. Prescriber orders erythromycin 500 milligrams PO times 1 dose as a bowel prep. How much diluent will the nurse add? Okay, so this is an oral one, right? So we have erythromycin for oral suspension, 200 milligrams per 5 mLs reconstituted. That doesn't tell me. Let's see. How much diluent will the nurse add? It's on here somewhere. There we go. Slowly add 140 milliliters of water. What's the concentration after reconstitution? That's right here. 200 milligrams per 5 mLs. Now, when we're saying concentration, that needs to be how much per how much. So if you have a question like this that comes up and it says, what's the concentration? Don't just put 200 milligrams. Make sure you put, 200 milligrams per 5 mLs or whatever the case may be. So how much will the nurse administer? So we want to know, oops. Oh, that was crazy. Here we go. We want to know how many milliliters per dose. Oops. And my dog is barking his head off outside. All right, so in 5 mLs, we have 200 milligrams. My order is for 500 milligrams for 1 dose. Pretty simple when it all comes down to it, right? And that's going to be 2.5 milliliters per dose. Oh, it's thundering out there. So we're going to administer 2.5 mLs. So looking to see, I don't think it says, oh, here we go. So 8 grams are what came in that vial, or that bottle to begin with. So it seems a little weird, doesn't it? So you've added 140 milliliters and you're going to give 2.5 ml. So it's quite a difference, but that's correct. Okay, so the prescriber orders cefabid or cefoperazone sodium, 1,000 milligrams IV Q12 hours for a client with an infection. How much diluent will be added to the bottle? So let's look at this. If I look at that for IM use, what is it? Oh, I'm giving it IV. So for IV, intermittent infusion, dilute in 20 to 40 milliliters of diluent per gram. So the bottle is 1 gram. So I'm going to pick, I can do it between 20 and 40. I'm going to choose 40. So I'm going to go with 40 mLs of diluent. So I'm going to add 40. You could add 20, that wouldn't be incorrect. You could add 30, that wouldn't be incorrect. So you've got a range there. If I have 40 mLs, what's my resulting, you know what, actually, I'm not gonna go with intermittent. I'm gonna back it up here. I'm gonna go with this one. Rather than going with the intermittent infusion. I'm going to go just for the IV use because that's going to give us our continuous infusion. Oh, goodness. All right, never mind. All right, sorry. Sorry. To look at this one a little closer. Okay, so, okay, back it up. I'm going to go back to the 40 mLs. So I'm going to go with 40 mLs. What's the resulting concentration? So if I added 40 mLs, then I would have 1 gram and 40 mLs, right? So I've got 1 gram and 40 mLs. How many mLs will the nurse administer? So mLs per dose. And 1 ml is, oops, 40 mLs, 1 gram. And I need to get rid of grams. I know that 1 gram is 1,000 milligrams. I'm going to use that because our dosing is written in milligrams, even though it's 1,000 milligrams. And I know that 1,000 milligrams is a gram. I'm still going to do my conversion because whenever you're writing these problems out on any kind of math test, you've got to convert in your problem. You can't do it in your head. So if you want to get your problems right, make sure that you do your conversions in your work, in your written work. Okay, so I've got 1,000 milligrams per dose. Okay, let's do the math. 40 times 1,000 divided by 1,000 is going to give us 40, right? Times 1,000 divided by 1,000 equals 40. 40 milliliters per dose. Okay. 40 mLs. Okay. And I could further concentrate, or I could further dilute that in actual practice if I wanted to. I may reconstitute that and then add it to a little bag of saline or whatever the diluent is. But that's it for our math portion of that, at least. Okay, sorry for my confusion about the diluent on that one. Apologize. Okay. Prescriber orders amoxicillin 500 milligrams PO Q6 hours for tonsillitis. How much diluent will be added to the bottle? So let's see here. 100 mLs when reconstituted. Add 1/3 total amount of water for reconstitution, which is 78 milliliters, and that's a little bit hard to read on there, but it's right here. Okay, so I'm going to add 78 mLs. Now this powder must really take up some space because that gives us 100 mLs. You see it right here, 100 mLs when reconstituted, and we've only added 78. So there's a little bit of volume that comes into play in the powder on this one. What's the concentration after reconstitution? Well, that's right there. I've got 125 milligrams in 5 mLs. How many mLs will the nurse administer? All right. Oh, it's not wanting to draw again. I'm going to try and redo, reset my pencil here. All right, what happened? Ah. Okay, that was weird. Alrighty. Should be working now. Let's see, fingers crossed. Okay, milliliters per dose. And I know that 5 mLs contains 125 milligrams. And I've got 500 milligrams per dose. Per milligram dose. And 5 times 500 divided by 125 equals 20 mLs per dose. If I were using a med cup, I would fill right to there. And I would look at that med cup from the side, remember? You guys, once you get into the lab, we'll do a little more with medication cups and learn how to read the med cups, but that's where it is on the med cup, right at that 20 ml mark. Okay, the client with chronic sinusitis has an order for amoxicillin 375 milligrams PO Q8 hours. What diluent should be used? So let's see, I've got amoxicillin for oral suspension, and here's my diluent right here. Add a total of 105 milliliters of water in 2 portions. Shake well after each. So I'm going to add about half of that amount of water, shake it up, and add the rest of it. What diluent should be used? That's going to be water. How many milliliters? 105. And how many milligrams are in the bottle? Let's see. All right, I know what's on here. Constitute 105. All right. Oh my goodness, here we go. Had to hunt for that one, 7.5 grams. So how many milligrams are in the bottle? Well, if it's 7.5 grams, 1, 2, 3, 7,500 milligrams. How many milliliters will be administered for each dose? So let's go with milliliters per dose. And My concentration is right here, 5 mLs. I've got 250 milligrams. And my order is 375 milligrams per dose. Five times 375 divided by 250 equals 7.5 ml per dose. And 7.5 mLs, how many doses are in the bottle? So if I've got a 150 milliliter bottle, another way I can figure this out is just to do 150 divided by 7.5. 150 total divided by 7.5 per dose equals 20. 20 doses. Okay, so the provider ordered amoxicillin suspension, 250 milligrams POQ 6 hours. What should be used as the diluent? Well, I'm gonna look on here. I've got water. Water. How many milliliters of diluent should be added? And it says it right here, 78. How many milligrams are in the bottle? That is mLs. I know it's on here somewhere. Oh, here we go. 2.5 grams. This is why I gave you guys all these different label ones, so you can really see like how things are found in different places on the labels. I mean, and you see, I mean, I'm an experienced RN, and I gotta hunt for them too, and I'm the one that put this together. So, how many milliliters will the nurse administer for each dose? Okay, so we're gonna say ml. Wow, it's doing it again. Doggone it. Reset my pencil again. I don't know why it keeps doing that. Okay. Huh. Let me get out of it and back in. It's weird. I swear, it only does this kind of stuff when I'm recording. Okay. How many milliliters will the nurse administer? So we're looking for, oops, mLs per dose. I'm going to use my concentration. I've got 125 and 5. So 5 mLs is 125 milligrams. And my order is for 250. Do this one practically in your head, right? 250 milligrams per dose. 5 times 250 divided by 125 equals 10 ml per dose. 10 ml. And I've got 100 mLs when reconstituted, 10 mLs for each one. That's going to give me 10 doses in that bottle. Okay. Client with acute bronchitis has an order for Cefaclor 450 milligrams POQ 12 hours. What should be used as the diluent? Okay, so it does not say that it's a pediatric patient. We're going to totally skip past the pediatric stuff. Directions for mixing: 62 mLs of water in 2 portions, So half, shake it up, half, shake it up. So 62 mLs of water, so we're going to use water. And 62 mLs. How many milligrams are in the bottle? That is, looking. Missing. I know what's on here. Here we go. Whew. 7.5 grams. Which is going to be 7,500 milligrams. How many milliliters will the nurse administer? MLs per dose. And my concentration is, I saw it, 5 mLs, 375 milligrams. My order is for 450 milligrams per dose. Okay. 5 times 450 divided by 375 equals 6. Okay, so we're going to order or administer 6 mLs. How many doses are in the bottle? It's going to give us 100 mLs when mixed, and 100 divided by 6 equals 16.7 doses in that bottle. So we're actually probably going to just use it for 16 doses in actual practice. Okay. Number 14. The provider orders penicillin G potassium, 3 million units IV Q6 hours for a client with ethmoidectomy. What's the concentration after adding 11.5 mLs of diluent? $1 million per ml. How many milliliters will the nurse administer? So milliliters per dose. And we have 1 ml, 1 million units. Also, if you haven't noticed, I always write out this millions. So make sure you do that when you're doing any tests that have numbers that are this high. Use your, don't write it 1 mil or anything like that. Write it out 1 million units. Our order is for 3 million units per dose. Need my calculator for that. 3 million divided by 1 million is 3 mLs per dose. All right, we're getting there. Number 15. The client has an order for penicillin G potassium, 600,000 units IM Q6 hours for a serious infection. How many milliliters of diluent will be required for the most appropriate dilution? So again, most appropriate. What am I using it for? So I want the most concentrated solution here. So that's going to be that last line there, 1.6. It's a little fuzzy there, but it's 1.6 mLs is going to give us 500,000 units per milliliter. And on this one, it's the per milliliter is what it says at the top here. Remember on that other one, it had it in the chart. It said it right on that section, but on this one, it says it right there. So another example of how they're written a little bit differently. Okay, how many milliliters of diluent? 1.6 mLs. How many milliliters will the nurse administer? Let's see, so milliliters per dose. That gave us 500,000 units per ml. And, oops, back it up. All right, sorry, 1 ml, did that backwards, didn't I? It's 500,000 units. This is why I always start with the numerator, so I don't make an error like that. It's a real quick way to catch yourself when you do write it and then it's like, oh, wait a minute, that's supposed to be up on top. Okay, and our order is for 600,000 units. See, I make those mistakes so you don't have to. I did it all for you. Just kidding. Okay, 600,000 units per dose. That gives us 600,000 divided by 500,000, which is 1.2 ml per dose. Right. The provider orders penicillin G potassium 1.2 million units IV in a single dose today. What is the concentration if 11.5 milliliters of diluent are added? So that again gives us 1 million units. And I am going to write it out. 1 million units per ml. So just not really space to write everything there. How many milliliters will the nurse administer? Okay, milliliters per dose. I know this seems a little repetitive, but with repetition comes expertise. 1 milliliter is 1 million units. And we've got 1.2 units per dose. $1,200,000 divided by 1 million equals 1.2 mLs per dose. $1.2 milliliters. Okay, the client has an order for nystatin oral suspension, 600,000 units PO/QID. Now, how many times a day is QID? Think about it. 4 times a day, right? BID is 2 times a day. TID is 3 times a day. QID is 4 times a day. And that's where we stop with the IDs. How many milliliters will the nurse administer? Okay, so we want to know milliliters per dose. And if I look on here, I want to know my concentration, 100,000 units per ml. So 1 ml is 100,000 units. My order is for 600,000 units per dose. $600,000 divided by 100,000 is 6. So that's 6 mLs per dose. Okay, pretty straightforward one there. Okay, provider orders ampicillin 500 milligrams IM Q6 hours for a client with pneumonia. How much diluent should be added to the vial? Okay, so I'm going to look here. For IM use, add 3.5 milliliters. What is the concentration after reconstitution? 250 milligrams per ml. And how many mLs will the nurse give? So how many milliliters per dose? And I know that 1 ml contains 250 milligrams. Got 500 milligrams per dose. 500 divided by 250, oops, is, got ahead of myself there, 2 milliliters per dose. All right, not too much to that one. Provider orders cefazolin 500 milligrams IM Q12 hours for a client with cellulitis. How much diluent should be added to the vial? For IM, 2.5 mLs. What's the concentration after dilution? I've got 330 milligrams per ml. And how many mL should we administer? So milliliters per dose. And I know that 1 ml has 330 milligrams. And I've got 500 milligrams per dose. So I've got milliliters, dose, let's cancel out. And so we have 500 divided by 330 equals 1.5. 1.5 milliliters per dose. It was actually 1.5151515, etc. But we rounded to the tenths, which is 1.5 milliliters per dose. Always remember your rounding rules. Stop it. All right. Last but not least, vancomycin 1,000 milligrams PO Q6 hours has been ordered for a client with colitis. How much diluent should be added to the bottle? All right, so I'm going to look at this one. Reconstitution. Distilled or deionized water, 20 mLs. So I'm at 20 mLs. And this one was water. Pay attention to what your diluent is. If it says normal saline or water, and if it specifies what to use, that's what you have to use. Okay, so this one's for oral, so that's going to be water anyway, typically. But, so 20 mLs, what's the concentration after dilution? Each 5 ml contains 250 milligrams, so it's 250 milligrams in 5 mLs, oops, in 5 mLs, which would also be 50 milligrams per ml, but I'm gonna, if all it gives on the label is 250 and 5, that's what I'm gonna put for my answer in a problem like that. How many milliliters will the nurse administer? So we have mLs per dose, and 5 mLs is 250 milligrams. And my dose is 1,000 milligrams per dose. Okay, so 5 times 1,000 divided by 250 equals 20 mLs per dose. Okay. All right, so that's the last one of there. If you have any questions or concerns, or you like, you know, look at something and go, yeah, you sure that's right? Because I think you made a mistake, Miss Evans. I don't think I did, but you know, I'm not perfect. But that should be good. So anyway, let me know questions, concerns, issues at all. Please feel free to email me, and I will get back to you. And if you want to get together to go through anything too, I'm happy to do that too. So, all right, see you on the next video.